show you how to work some of this. So you're gonna go, once you've downloaded it, you're gonna go into packages and you're gonna search hypothesis testing, click on it, and then here's the description page, right? So you have all the names of the functions and then what they do. It's easier to read, obviously, if you click on it. It'll give you the thing. It'll give you the description for it, what it does. Right, so half of these are for confidence intervals and half of these are for hypothesis tests. It's the way I made it, it's only doing test stats, so it's only doing one part of the p-value, and it's only doing margin of error, so it's not doing upper, lower bound. Some of them have instructions on how to do upper and lower bound, right? So we have upper and lower bounds using the same inputs that you use to find the margin of error. It tells you how to use the same ones to calculate upper and lower bounds. Right, so for hypothesis testing, you have test stat. This is the basic one, right? You have the parameters, tells you what the parameters are. I'm going to show you how to, this is the most complex one because it tells you the most information, whereas the other ones, it's kind of, I haven't tried, but I'm pretty sure you could, when they give us the data set, like you should be able to just put a vector in and say like the mean of a vector, and you put it into the x bar, like, the actual function, like mean vector, and it should give you. But like if you just put a vector in, like, it's not going to calculate the mean for you. You need to do the function within the x bar. You know what I'm talking about, right? Cool. Okay. So yeah, you have confidence interval, you have error margins, the basic error margin thing, and then you have hypothesis testing for test statistics, right? So this is the most basic one. And then these two you ignore, and then this one, it might not be useful. It's only if you have this information. So it's for determining significance level. I didn't do determining power level. I didn't do anything with pooled standard deviation. And I didn't do anything that actually calculates the p-value or the upper and lower bounds, as I already said. Those are the things that are not here. And also bias variance, well, that's not here. But you have the stuff that it would typically take a long time to pop in. So like this one, if you remember the formula for this, it's fucking awful. But I made it so that you can just enter these parameters and it'll puke it out for you. So, yes. And I suggest clicking on these and reading this part. I also suggest really making sure that you're putting the arguments in the correct order here. So like if you flip mu and x bar, you're gonna have flipped the hypothesis sample mean and the actual sample mean. So I'm gonna show you how to use test stat. Yeah, because that's the most complex one and it's the one you're probably gonna use the most. So it calculates the basic test statistics, Z or T. So T, obviously, if it's large, if it's small, and you're gonna do that here, I'm gonna show you in a sec. So yeah, let's start. Test statistic. We're gonna use this problem. So first we have to get sample mean. So that's gonna be 3.74, right? 3.74. And it said that the hypothesis sample mean was 3.8, and then it said the standard deviation was 0.87, right? Yes. And then the population size is 65. So this is the information they gave us. For all of these functions, you only have to use the information you gave us. You'll never have to like make a proportion yourself. Like you'll always just put in the numerator and the denominator for the proportion and it'll do it all that. So yeah, so now we need to know, we need to tell it whether to calculate the z or the t. So you do z if the sample size is big enough. So you're going to go, since it's 65, that means that the population size is big enough. So you're going to go large, true, capital true. Fuck, my caps lock button is broken. True. And then, so right here, it will, if you put in the information, do you hear my family yelling? That's great. So right here, it's telling you that we want the alternative hypothesis to not be equal to the null. So right here we're going not equal. So comparison, that's not how you spell comparison. Alright, so this is all the stuff for this problem. We have the values they gave us. We know that the sample size is large, and we know that we want the alternate hypothesis to be not equal to the null hypothesis. So you enter that, and it gives you the test statistic, and then also what you need to calculate the p-value, which is what this question is asking for, is and compute the p-value. So we've only done the test statistic. So you can do this manually. I did have functions to do these for you, but it increased the amount of functions I had by a factor of 3, and it was fucking impossible to try to find anything in this list, so I just got rid of it, and I made some of the functions spit out how to calculate the p-value instead. So let's do p-value, right? So it tells you to multiply by 2. P-norm, that's not how you spell. And then, I probably should have this, but I didn't put it in. You have to do the absolute value of this whenever you have to do the absolute value of a test statistic whenever you see low f. So right? Alright, so this is all the information it gave us. And this will calculate the p-value. There we go. Oh, look at that, baby. Clear as day. Yeah, so let's do something where it's not large enough, so we'll just make this up. So test stat, let's do like, let's go in here. Test stat, so the sample mean will be, let's do like 7.2, and then the expected is 7.5. And then standard deviation, let's do like 0.9. And then the sample size will be 10, because that's not large. Because that's what I'm showing you, is how to do not large. So large equals false, bitch. And then for comparison, let's pretend that we need the alternate hypothesis the alternate hypothesis to be greater than the null hypothesis. So let's do greater than. And it tells you how to do this, right? And then, alright, put that bitch in, right? So this is information you need to calculate the p-value. So it's going to tell you the function that's P, T. It's gonna tell you to put low F because it's greater than, and it's gonna tell you the degrees freedom because we're using PT because it's too small, right? Yeah, that's for T, that's information you need. So we're gonna PT, absolute value of this. We're gonna go 9 degrees freedom. We're gonna go low F. And that is your p-value. So I just made this problem up, but yeah, you would get how it would be helpful if, you know, you actually got things to put in. So yeah, we can do, maybe let's do a error margin. Let's do some basic error margin stuff. So let's get a problem from, not that. Yeah. Okay, so a random sample of 123 cases. Sample mean surgery time. So this is N. This is X bar. Right? This is a confidence interval, not X bar. This is X bar. This is standard deviation. Yeah, I know it's sample standard deviation here. Just you know what it means. That's where the standard deviation goes, whatever it is, if it's sample or population. So let's do error margin. Okay, so confidence interval expressed as a decimal, because that's what I said to do. 95, right? 95, comma N. N is 123. Standard deviation they gave us was 22.6. Alright, and so since this is large, since N is large, we can go large, true. Fuck. Oh, right. Decimal. I didn't follow my own instructions. Okay, so this is the error margin. It tells you to make sure that you're just doing the error margin and that you still have to calculate the upper and lower bounds. So we're gonna go, alright, here's the problem. This might be too exact. It might hate me for this. So 993, right, because we're 3 decimal places. Bang, bitch. Right, so, okay, that's actually literally my fault. Okay, anyway. Yeah. And then it doesn't tell you how to do this, but you know how to do this because you can just go, oh, what's the mean? Okay. 36.9 minus error margin. Alright, that's what that is. Lower. Yep, and then we're gonna go 36.9 plus. The fuck, bitch? Oh, right, oops. Motherfucker. The best part of this is that you can see how competent I am with a keyboard. Also I'm fucking freezing, so. That's crazy. And yeah, you're fucked, because I didn't give you a way to solve this. But, yeah. So, easy peasy. I'm sorry that this is 15 minutes. Yeah.